Hey friends, I'm Scott Hanselman. I'm going to chat with you about Linux and Windows and .NET and how they all fit together, and they are wonderful. It's important to remember that .NET doesn't just run on Windows. It is open source and it runs everywhere. Linux and IoT devices and Android phones and iPhones and all over the place. Now, I'm going to switch over to my desktop and show you I have Windows 11. You can use Windows 10 if you like, but you're going to get a lot more features if you're on Windows 11. So if you can upgrade, do. I'm going to go to the Start menu here, and I'm going to type in Terminal. We're going to set a few things up to start. If we're going to be doing this work, we're going to be at the command line, and we have a couple of choices. There's the old classic command prompt, but then there's the new wonderful Windows Terminal. I would encourage you to use that instead. And now when I run the terminal, I'll bring it over here. I can click on this chevron here, and I'm going to click Settings. This is important. We're going to double check this. I'm going to click on Settings. We're going to make a note of this choice here, Default Terminal Application. You're going to want to make sure that that's set to Windows Terminal. Okay, if you do not have that choice, then you may have an older version of Windows. But if you have a newer version of Windows, you'll have the choice between the classic console host and the new Windows Terminal. If you select that Windows Terminal, then whenever you launch something, whether it be launching the command prompt or PowerShell or Linux, you'll get the new Windows Terminal. The benefits you'll have are many. You'll have this drop-down menu, and the Windows Terminal will in fact look on your system for all of the different shells that you can run, and you can see that it's detected a number of Linuxes that I've already got, and it's also detected some developer command prompts that were installed with Visual Studio. You can see also that PowerShell here is boldface. That means that that's my default shell. And we've got our classic Windows PowerShell up here and our command prompt, our original DOS command prompt. You don't have to use PowerShell. I like it. I'll show you what it looks like here in the Windows command line to start. What you can do is you can type WSL --install. So you should be able now to go out to a command prompt, type WSL --install, and it will set your system up to go and run the Windows subsystem for Linux. Now what it's doing behind the scenes is there's this thing in Windows called Turn Windows Features On or Off. It's kind of a very old control panel. If we go into that Windows Features On and Off, it looks like this. It's a little bit scary. If we zoom in down here, we see a bunch of different choices. The one that we want is the Windows Subsystem for Linux, and in the past, when you set up the Windows Subsystem for Linux, you would need to check a bunch of these and then turn them on and off and reboot, and it was all very confusing. In fact, WSL --install does that for you, so it'll set your machine up to do exactly what you want. Now you see this word hypervisor here, and you might think about Hyper-V, right? Hyper-V lets you run virtual machines on Windows, but we're not going to be running a full virtual machine. We're going to be running a lightweight utility virtual machine. So we don't need to have Hyper-V. And this is really important and really cool because not everyone has the professional version of Windows. You might have the home version, and we wanted to make sure that the Windows subsystem for Linux would run on home versions. That way students and people who don't have Pro would be able to use it. So you don't need to do any of those things, but it's nice for you to see that that exists. And you can just type WSL --install. Now I can type WSL --list. Excuse me. --list -v. And we can see on my system, I've already got a number of Linuxes installed. And the star here by Ubuntu indicates that that's my default. Okay, let's type WSL --help. We'll get a whole bunch of help. Let's see if we can parse some of this because there's a lot that went by right there. Look at this. WSL --install has some choices, and you can say for a list of valid distributions, use WSL /list /online. So let's do that for a second. WSL /list /online. We'll clear our screen here and we'll type that. Let's see what happens. The following list of distributions can be installed, and it's actually giving us a choice. I can say WSL -- install Ubuntu, which I already have, or I can pick one of these other ones. Now, this is super interesting. Where do you think those are coming from, and what does it mean to install Linux on Windows? Well, in fact, that's downloading tar files. It's downloading all of the distribution that you would want. And where's it coming from? Well, these are in the Windows Store, and this is super cool. We can actually click on the Windows Store. Would encourage you to do this as well. And we can go to the Windows Store and we can search, literally search for Linux. So I typed Linux into the search bar of the Windows Store, and it finds Linuxes, which is cool. You've got SUSE, and there's some weird stuff in here that's not Linux. But what we want to click on here to get the latest WSL is the Windows Subsystem for Linux preview. And in the future, we're going to see that stay in the store, which is going to make life a lot easier. So if you want the latest update, you have Windows 11, you go in here to the Windows Subsystem for Linux preview in the store. You can install it from the store, and then you'll get updates. You'll get really cool updates to the command line tool, to that WSL.exe. So when I type WSL -- help, I have some features that you may not have, and we'll talk about those in a little bit. Okay, so I said WSL -- list online. Ubuntu is a good default, but you can have as many of these as you want. Okay, you can install as many of these as you want, and all you have to do is say WSL -- install, and I'll install Oracle Linux right now. And then you'll notice a progress bar is going to appear down here, and it's going to start downloading that from the store, and it's going to install that Linux. And we'll come back in a little bit. Oh, well, looks like it's so fast, it's going to happen now. I thought we would have to take a break. There you go. Wow. Oh, look at this. So that just brought down the tar file for Linux, and look at that. We didn't have to wait. We just installed Linux on Windows like that. Wow. So this is Oracle Linux on Windows. And then when we pull, we're going to go ahead and close the terminal here. And I'm going to run the terminal again, because it's going to detect that I've got that new Linux distribution installed. So I'm expecting a menu item to appear. Look at that. Oracle Linux 8.5 just appeared. So I now, on this machine, have Ubuntu, I have Kali Linux, I have Debian, and I have Oracle Linux. You can have as many of these as you want, which is great for testing, and it's great for learning. And then, again, this will work on Windows 11 Home as well as Pro, which is cool. Now you see that when I launched my Windows terminal, the first one that popped up here was PowerShell. That's my shell. That's not Linux. This is just a shell. This happens to be the Windows PowerShell. I'm actually going to click here and say Ubuntu. Okay. And you notice that my prompt here is very colorful. So I have the same prompt in both Windows and on Linux. That is a prompt that is from a open source project that is called Oh My Posh. O, like OH, my posh. And you can see that at ohmyposh.dev. And this is a little thing to note. It's a prompt engine for any shell. Even though Posh might imply PowerShell, in fact, it works everywhere now, and that's a good thing to remember. This doesn't have anything to do with Linux explicitly. It just makes the command line experience awesomer. So you can see here on the Oh My Posh website, you can get started. You can install for Windows, for Mac, or for Linux. So I happen to have that prompt installed on my system, which means it looks cool in both places. I spend a lot of time at the command line, and we're going to spend time at the command line here in Linux, but I want to assure you that this is, in fact, Linux. In fact, we have Ubuntu 20.04, and then this over here is just Windows. All right? And I can switch between those tabs as much as I want. And then if you're curious, that is a human heart that is indicating the health of my current last command. And this is my blood sugar, because I'm a type 1 diabetic. So I like to keep that in there. And then I can also go out to different projects that I work on, and you'll see that I have the different bits of code, and I have both my blood sugar, the current version of .NET that I have installed, and then here I have my Git prompt. You can put whatever you want in there. You can put flags and emoji, you can put your battery life on your laptop, whatever makes you happy. Okay? Now, if you're in Linux on Windows, you might think about the task manager and wonder, what does this look like? Where is this running? So I'm going to right click on the start menu. I'm going to fire up the task manager, which is going to appear on another monitor over here. So I'm going to have to go and get it and bring it to you. I have too many monitors. We'll go all the way over here. There we go. And we're going to look at our VM mem WSL. You can see that we've got a process that's managing this utility virtual machine. Now that is going to go up and down in size depending on how many of these that you have running. And you can go and say WSL --list -v, and you can see how many are running. So right now we see we have Ubuntu currently running. Our Oracle one stopped. It fell asleep. We're not running it anymore. Our Docker is running. We'll talk about Docker in a little bit. And the other ones are stopped. But if we go back and we start up that Oracle Linux again, okay, we return here and we run WSL --list -v, you'll notice that Oracle Linux now says running when before it said stopped. Okay. Those will come and go depending on whether or not you're using them. And you can monitor that, of course, from WSL --list. The -v lets you see verbose. It lets you see that state and that extra information. So I have a tendency to always just run -v. All right. Here we've got the Oracle one and we've got the Ubuntu. I can even run them in split screen, which is cool. So here I've got Oracle Linux. I'm going to hold down the Alt button with my left thumb, and I'm going to click on that, and I'm going to get a split screen. So now we've got Ubuntu right here, and we've got Oracle down here, and I can do that as many times as I want. If I was in fact going to test Debian here, and then maybe I wanted Kali Linux up here. So you can do whatever makes you happy. Okay, so we're in Linux, but we're also on Windows, so that's a little bit weird. Remember that a virtual machine historically has just been a square. You are running Windows, you're running Mac, and then you start a virtual machine and it starts up, and then you have a square within another square. Like I'm running Windows and it's living inside of this square, and then I might have another window which is a virtual machine inside it. We wanted the Windows subsystem for Linux to feel integrated into Windows. So how do we do that? Well, what's going on in the file system? Is the file system integrated? Here I have home/Scott, but if we go to, let's say, PowerShell, and I look at the current directory, we have C:users Scott. That seems like a different file system. If I type df and I look at my file systems, here we can learn some interesting stuff. We can see all the different file systems, and we note a couple of interesting things. We have some mount points. If you're familiar with Linux, you'll note that you can mount directories to other file systems. So in fact, mount C, D, E, and F on my particular machine are other file systems. What if I went over there? What if we went to cd mount cdc, oops, and then I'll go users Scott and desktop. It might be on my OneDrive. That's why I can't find it. All right. So look at that. We are on Mount C users Scott OneDrive desktop, but I'm looking at it from the perspective of Linux. So we're seeing the Linux view on a mounted file system. Now this is going to be a little bit slower, and this is a really important thing to learn when you're starting doing WSL on Windows. If you do your work on Mount C users whatever, or Mount C source code, it's going to be slower than if you do that work on the native Linux file system, because you're effectively on a network share. It just happens to be your own machine. You're going through some layers. Not really a network share, but you get the idea, okay? So I'm going to go back home and I'm going to do my work here inside of /home/Scott. But remember that I said things should be very integrated. We want it to feel like Windows. How do I like edit a text file? Like I can type VI and I can say hello.txt and it will run VI, and I can do something and say, hey friends, and then close it just like you do. And I can see that hello.txt file is here, right there, hello.txt. But where is it? It's in C Home Scott. Okay. I typed VI, which is the text editor for Linux. Could I run Notepad? Well, Notepad's a Windows application and we're running Ubuntu. But are we? I mean, we are in Windows. So what kind of lines can we blur? What if I type Notepad? Well, command not found, right? Linux doesn't know about Notepad, but we own the kernel here. We have a fork of the Linux kernel, and you can see the source code if you want up on GitHub. So what if I said notepad.exe, and then we let Linux say, you know, I don't know what that is, but maybe Windows would know, and then we pass it along. We pass it along. I could say notepad.exe, and look, Notepad pops up. Notepad.exe. That's cool. So then what if I said notepad.exe hello text? All right, now we're cooking. What's going on here? We have opened a Windows app from Linux, passing in the Linux file name, and now we see it inside of Notepad. Now you might be familiar with things like carriage return, line feed, and some of the issues that we've seen over the last many years, where carriage return line feed, which is an ASCII 13, and LF, which is an ASCII 10, can be a little bit challenging because Windows includes carriage return line feed, but Linux only uses a line feed at the end of a line in a text file. Well, many years ago, you probably didn't notice it, but in fact, Notepad was updated to support Unix line feeds. You can actually see that right there. Okay, and when we go and we say save as, where are we saving? Where are we saving? Well, we can save on our PC desktop, but we have other places as well, and we'll show you that in just a second. So can we make a change to this? Hit save, close it, and then I'm going to run it in Vim or VI again. Look at that. So you can open your text files, open your source code, and do it in either Linux or in Windows, and it will maintain those line endings, which is really, really cool. Historically, you couldn't do that. The reason that that worked is because of this. Let's type this. Let's type explorer.exe. That's the Windows Explorer, except we're going to type dot. So we're saying explorer.exe dot. And look what happens. Look at this. The Windows Explorer started up. Okay. But where are we? Where are we right now? Let's make a little room and let's take a look up here in the corner. We are on WSL localhost. WSL localhost, Ubuntu Home Scott. Now remember that from Linux, we were able to have a mount point to look at the Windows file system. Here we're kind of doing the opposite. We're in the Windows world and we are looking at the Linux file system. What's the best way to do that? What's the easiest way to do that? You do it with a local network share. So WSL.localhost looks like a share, looks like it's over there on another computer. It's not, it's this computer. Talking back to my own computer, and I can see all of the different Linuxes, including the new Oracle one that we installed a few minutes ago. I can open up Ubuntu 2004. I can then go into Home Scott, come down to the bottom, and we can see our hello.txt sitting right there. So that's interesting. That means I could potentially open that in a number of ways. I could even right click and say open with, and I could say Notepad or Visual Studio Code or whatever. Open with Notepad, and there's our application. And again, we note that the line feeds are correct. How cool is that? It's important to note how we can move forward and backward within these experiences. And it also shows us how really well integrated WSL is with Windows, right? It's not just running a VM. If you're running a VM, you have a square and a square, and getting files back and forth can be challenging. Shared clipboards is challenging. With this, we look at the Windows Explorer here. We've got Dropbox, we've got Microsoft where I work, we've got a disk, we've got my PC, and look, Linux, the little Linux penguin, we've got Tux. Tux, the Linux penguin, is hanging out, chilling inside of my Windows Explorer. So Linux is a first-class citizen here inside the Windows Explorer, which is pretty cool. Now, check out what else we can do. If we can do that, I can come here to the Start menu. I can say All Apps. We can go down to U for Ubuntu. I can open this up, and I can actually see graphical applications that are installed. So I've installed from Ubuntu some graphical applications like this image manipulation program, which is kind of like open source Photoshop. We can go and run that. That application is called the GIMP. I'm going to go ahead and click on that. That's going to fire up. And look, I'm going to bring it over from this monitor. What's going on? Look at that. This is interesting. So we have a Linux application running, looks great, moves well, but look at my cursor, look at my Windows. It looks like Linux. That's because it is Linux. Okay, that is a Linux graphical application that is running on Windows and WSL. So then when I say open, right, where is this going to come from? If I say open, what file system is this? Well, this dialog box is not a Windows dialog box. If I say file system or file system root, we are looking at the Linux file system. So if I wanted to get over onto Windows from here, I would have to go Mount C, like we did before, remember? Users, Scott. I'll go into, my downloads or my OneDrive, right? And then I could go and open something up, okay? So here we've got, PDFs, or I can open up, let's see if we have any, do I have any, I don't know, any pictures? Any pictures in here? I could open up pictures, and I could go and edit those inside of this application, and they're going to look right, they're going to move right, and I can then save as or save a copy, and I can see them either on the Linux file system or on the Windows file system. That means if there's a particular application that you're interested in and you want to, you can run it. Windows apps, Linux apps, all existing very, very nicely inside of the WSL file system on Windows 11. That's pretty cool. Okay, let's go back out here and we'll go to we're here in Linux, and I'm going to say sudo apt update because I want to point out that it really is Linux, and I can go and make sure that my Ubuntu is completely updated and ready to go. I want to make sure I've got all the latest upgrades. You would do that kind of work just like it was any old Linux machine, because it is in fact any old Linux machine. And you can say that here it wants to go and update some stuff. Here's where we start talking about .NET. And thanks for sticking with me because I think it's worth understanding these things. Notice I'm actually getting updates from .NET for .NET and the .NET SDK using my regular Linux tools. .NET in this context is just another member of the family, and that's really important to point out. So I'm going to say no in the interest of time, and I'm going to say .NET-info, and we're going to take a look at what .NET we have here and what's going on. You can see that I've got .NET 6 on this one. I could install the new .NET 7 that's coming out in a few weeks. We're on Ubuntu 20.04. And then more importantly, I can see the base path. I can see the location that .NET is. I can do that another way by saying which .NET. You'll see that .NET is located in user bin .NET, and that's actually pointing off to the user share with a bunch of different .NETs, because you can have multiple .NETs installed on any system, and then the SDK will pick the right stuff. And then here we see a number of .NET runtimes for both .NET apps and .NET web apps, .NET ASP.NET web apps. How would you go and install this? Well, a couple of different ways. If I go over to the documentation, I can go to the .NET website. We'll start at the beginning here. If you start at the .NET website, And I want to actually remind you, if you're looking at this video, because it may be recorded for some folks to look at later, then you're going to see that on November 10th, we have .NET Conf, the .NET Conference. You can learn about these things. That was recorded as well. So no matter when you're watching me spend time with you, you can go and check that out. If I click download, I want to point out that we have Windows, Linux, Mac, and we have Docker. You can click on one of those and then hit install, and it'll walk you through the process. This is really interesting. On Linux, there are many ways to install .NET. On Windows, you run the installer. But on Linux, you can do it a couple of ways. You can download tarballs. Tarballs are just zip files. You can do a scripted install. You can run a script, which will download the tarballs for you. You can grab the binaries yourself if it makes you happy. But I recommend using the official package archives. So in the context of Ubuntu, you can just get them. They're in there. If I actually go to packages.ubuntu, you can see we have versions of .NET sitting in Ubuntu right now ready to go. And then we also have packages on the Microsoft website. So you have many, many, many ways to do that. And then, of course, if you install them from the .NET packages.microsoft.com, they are supported by Microsoft. So that's pretty cool. CentOS, Debian, Fedora, OpenSUSE. This one is, I always forget the SLES, what it stands for. And Ubuntu, they all are supported by Microsoft, which is really, really cool. And then if you can also do other distributions, like Alpine is very popular, and you can use Snap to install as well. These things all work, and they work great on Linux. So let's do a couple of quick experiments. Let's just make a test application. I'm just going to make a folder here and go into that test application, and I'm going to say actually, let's do ls. We'll make sure we have an empty folder here. I'm going to say .NET new console. Okay, and then let's just take a look at that. Now we see we have program.cs. I can say vim or vi program.cs, and we can see that. Okay, we want to see that, we can do that. That's on the Linux file system. Okay, so then we're going to say .NET run. And we're going to say 1000, 1000. Took about 2 seconds. Well, why is that? That's because .NET Run actually built the application. It went and it restored the packages that it needed. It built it, and then it ran it. Because .NET Run is an SDK command. Remember that the .NET command that we're running is there in user bin.net and linked over to a share is compiling that hello world. We'll say it again, 1000. A little faster that next time. But now we have a new folder, this bin folder. That was not there before. We didn't have a bin folder before. Let's go in there. I'm going to go and say push D, and I'm going to save this folder. And I'm going to go back down into bin, and into debug, and into net6, and I can see my application right there. Let's look at it like this. You can notice these X's are indicating that this is an executable application, and that's why it's got the little star and why it's been colored green on my particular installation of Ubuntu here. That means I can just run test app. Now, interesting. Notice that I didn't go 1000, 1000. I just went run. Okay, you can run that app. That is a Linux application. It's only 142K, and you can run it right there, just like that. All you need are the .NET runtimes. That's how you make your applications. Now we're going to go and we're going to say popd to return back to our test app folder. And we see that folder right here. So I could also run Notepad. Oops, remember, notepad.exe. And I could write my code like this. Now we're using the new .NET 6, so you know here that we have the new console template. So there is no public static void main. That has been implied, and you can learn more about that if you want to, but that makes it really easy to just sit down here and then change your code. Hey friends, and then we'll go back and we'll say .NET run 1000 hey friends. Very nice experience. Well, I could also type code dot. Now this one's a little tricky. Remember how I said before you should say .exe? We're not going to do that. We're going to say code dot because Visual Studio Code is special. Visual Studio Code is more clever than Notepad. Watch carefully. I'm going to hit code. Look, 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 look. Updating VS Code server. VS Code server. What's a server? What's that about? What's going on? Unpacking. What's the deal? VS Code server. What's that? Well, Visual Studio Code just popped up, just appeared on my window here. And it's the Visual Studio Code that I'm used to using. It looks like Visual Studio Code. It's got all the menus and everything that I expect. It doesn't look like a Linux application. It looks like Visual Studio Code. If I click on the Files button in the corner here, I can see my program.cs is right there. So what's going on? Is this a Windows app or is it a Linux app? Well, down here in the corner, it says WSL Ubuntu. And then before, it said VS Code server. That's weird. Let's type htop and let's see what's going on. Maybe something is happening here. Let's see if we can find something. This is actually a little bit hard to see. My apologies. There it is. Look. On the Linux side, VS Code server is running some processes. That's interesting. But if we go and look at the task manager, we know that Linux is running, and then we know that VS Code is running right there. Okay, that's interesting. So we have Visual Studio Code split in half. Half of it lives in the Windows side, and the other half, look right there, lives in the Linux side. Okay, well, which half and why? Well, when you're here and you type something like console, and this drops down a IntelliSense window, this thing says, hey, I know things about .NET. I can help you with that. I can make it so WriteLine is easier. Who got that information? Where did that pop come from? That came from a language server. That came from a language server, and that language server needs to run somewhere. So where is that running? Let's take a look at our extensions. We have something really, really interesting here. We have our local in Windows extensions. I have some C++ things that we're not using right now. But then look at this. C# lives in this instance inside of WSL. So these extensions have location transparency. There's one in WSL and there's one in Windows. So in this context, Visual Studio Code has split in half and become a client-server application where those language servers are over there in Ubuntu, which is my local machine, and then Windows is doing this. So when I hit that dot, that language server spoke across operating systems. The Linux language server for C# just popped that down, and I can go and write stuff. Hey, I am on Linux. And now we can do something interesting. I've been trying to show you Windows Terminal and how great it is, but a lot of you prefer Visual Studio Code. Visual Studio Code has its own terminal as well. So look, here we are inside of Visual Studio Code. I've got Linux right there, and then I've got my code up here. Can we run it? 1002. Look at that. Okay, but can we put a breakpoint and then go and do a debug and then run it? We can do that as well, right? Start the debugger, and then there we are. We have actually dropped now into the debugger, and we're doing live debugging on a Windows machine using the Windows version of Visual Studio Code, except we're talking to Linux. And we can prove that. We can see that because those DLLs were loaded off of user share.net. Isn't that cool? Isn't that cool? All right. Well, that is a simple hello world. Let's try something a little bit different. Let's go up a bit and let's go and say test web app. Okay. We have an empty folder right now. All right. And let's say .NET new, and then what are some of the choices that we have? Here we go, .NET New Web App. All right, going to have a little bit more than a console application. And then we can say code dot, fire up Visual Studio Code. We've got our pages, we've got our CSS in here. We can go into our index page, say welcome. Hey, I am on Linux. Hi, friends. Okay. We can do that either from this terminal or the other. .NET Run. I'm going to go and build that ASP.NET application, and then it's going to pop up, and you're going to notice something interesting. It says it's listening on local host. It's listening on an HTTPS and an HTTP, so a secure port and a non-secure port. What's localhost? Is it the Windows localhost or is it the Linux localhost? Well, what would you expect? What is the principle of least surprise? I would assume that when I click on that, it's actually going to just work. So here, hey friends, hi, I'm on Linux, just worked. So what is port 7036 and who's listening on that? Is that a Windows process listening on a port? I'm going to go and run TCP view. TCP view is going to pop over here, and we're going to go and look at that port. I think the port was 7036. Let's look for that port. There it is. Here's port 7036. We click on that and look, we can see the little icon there, the little tux. This is the little, well, not a tux actually, that's the WSL blue little penguin dude there. WSL host, which is an executable we haven't seen yet. We've never seen WSL host before, has just popped up. And that is the Windows process that is in charge of that port and is listening on that port, who owns that port, and is then brokering, who is then forwarding that port internally. Because if we go back into Linux and we ask ourselves, like, what is localhost? Well, we look at ifconfig, which is actually a network tool. Looks like I'm going to need to install that real quick, which is kind of cool. So we're just going to install that network tool real fast, which is also cool because you can just follow instructions. ifconfig, there we go. We can see that I've got a private network here of 172.21. That's my internal network. We're going to automatically poke stuff over to me. So right now, here, localhost from the point of view of Linux is local to my machine. This is .NET running on Linux on localhost 7036, and then we've port forwarded. We've forwarded that port over to Windows so that when I run the browser, it just works. That's what I would have expected it to do. The principle of least surprise. I want to click localhost. Otherwise, I got to go into the browser and I got to type 172. It's a hassle. So you get port forwarding automatically, which is cool. All right. Now we're going to come back out to the command line, and I'm going to type Docker. I'm going to take Docker images. Now containers are a big part of the the Linux world. And if we look at this, look at these Docker images. Let me make myself a little bit smaller here and get in the corner. And we'll say Docker images. I'm in Linux and I'm looking at Docker images. You can see that I have a bunch of images here. Some of them I made a couple of weeks ago, but some have been around for a while. So you can see I've been developing on Docker for a long time. And I can actually see some stuff that I made as many as 4 years ago. Okay. I've got a couple of things that I've been doing with my own websites. Like here, I've got my podcast. I have a podcast called Hansel Minutes. You should check it out. If you go over to hanselminutes.com, here's the podcast. I've done over 862 episodes, a lot of cool people. So I wrote that website, and that website publishes from a Docker container. So let's look at this. Let's say Docker build. Oops. Oh, this is great. So in this case here, I'm running a PowerShell script inside of Linux. And of course, I haven't yet installed PowerShell in Linux. So I'm going to go and just grab this little chunk of text right here. It was just a one-line script, and I'll run that manually. So we're going to say docker build -t for tag. We're going to build that entire thing here in Docker. So while this is happening, how is this happening? I'm going to make this full screen. While that's happening, I'm going to right-click and I'm going to hold down with Alt there on PowerShell. So I've opened a split screen. I've got stuff over there on the far corner building. Over here at the same time, I can still say Docker images. I can run Docker from Windows or from Linux. Okay. And we can see that these are shared. And I'm going to say WSL-V, and you'll note that we've got this Docker desktop running. So Docker for Windows on a Windows machine is a desktop application that you can install. And I can see those containers, see those images, and it is in fact using WSL. It's using Linux, because now that we have Linux available to us on Windows, why not use it? And now I can run Docker, build my apps in Docker on the Windows side, on the Linux side, and then I can then deploy them up into the cloud. So you see how I'm very seamlessly moving back and forth between Windows and Linux quite comfortably, building Docker containers, and then I can deploy them as well. So if I switch over here into, for example, into Azure, you can see all the different applications that I'm running. These are my personal apps. And we've got that Hansel Minutes website running on Linux. Okay, look at that. That's running up in the cloud on Linux. And I can deploy that in a number of ways. I could just publish it with a zip file. I could publish it with a GitHub action. I could publish it with Azure DevOps. So for example, if we go here, let's take a look at my Azure DevOps, where I do the building of this container, which could be built locally or could be built in the cloud. And when we show up here, you can see that the Hanselman website, the Hansel Minutes website are all built in Azure DevOps. I can look at those pipelines, see that on Tuesday that was run. It ran for 1 minute and 36 seconds and then published out into Linux. So what this means is that I'm on a Windows machine. I'm going to ultimately deploy into a container in the cloud somewhere. I can test it locally. I can run both on Windows and on Linux. It's a very comfortable experience. I can use Visual Studio Code or I can use Visual Studio. Windows does the right thing. I can make a Docker container. I can then push these changes up into Azure DevOps, or I can push them up into GitHub Actions. I'll give you an example of GitHub Actions as well. And then when I do that, I can follow up by sending it to off into Azure. So here I've got actions running in GitHub that will go and then build and deploy my .NET Core application. So you've got the ability to do this stuff right now. You've got Windows 10, you've got Windows 11, you can run WSL. It's really easy. Go into the Windows Store, type Linux. You can install that preview if you want. That gives you the latest features, and it's better because you can get updated from the store. Or just go out to the command line, type WSL --install, and then you can be running Linux and Windows side by side. You can run as many Linuxes as you want. Then you can go and install Docker Desktop. That's going to give you a wonderful development experience. And I can go around, whether it be in Visual Studio like this or Visual Studio Code, and do these deployments. Check this out. Here's Visual Studio on Windows. It has WSL and IIS as a choice. It's all about choice. We're having a great time building this stuff for you. Thanks so much for having me spend a little bit of time with you today. I hope you enjoyed this talk, and I hope you have a great rest of your day. Thanks.